everyone. So I hope you got the time to uh, think about this problem a bit, right? So I'll tell you how do you proceed with such questions and what should be the format of a coding interview, right? So whenever you are given a question in a coding interview, right, the first thing that you need to do is come up with a overall strategy even before writing a single line of code. Okay. So so you need to take maybe 1 or 2 minutes to think about the problem deeply, right? So you can just say to the interviewer, so let me just think about this problem for 1 or 2 minutes, and then I'll come up with a strategy. Once we discuss the strategy, we can move ahead to the coding part. And this is what the interviewer also expects from you, as to whether you are able to come up with the overall strategy. Because if you start coding, you might, deviate from whatever you are thinking. You might go in random directions. So it's always wiser to first come up with a strategy, discuss that with the interviewer, and then move ahead to the implementation part. Okay, because half of the question is solved uh, in the strategy itself, right? So if you are able to come up with a good strategy, you will be able to code it up, right? So that is the first part. Of course, when you start coding, he also looks at how you are thinking and how you are communicating each of the steps. So this is very important. So let's say you know some question in a coding round, okay, and the interviewer gave you a question, and you just coded it up in, let's say, 5 minutes, and that's it. It did not say anything. You came up with a perfect answer, and you just coded the solution. So in that case, what will happen is that you will not get selected. As simple as that. Why is that? That is because the interviewer wants to know how you are thinking, right? And if you are not able to communicate with the interviewer during the interview, it does not make sense, right? So if he wanted you to just solve the problem, he could have given you this as a assignment, right? But since that is a coding interview, he expects you to communicate throughout the interview. You have to keep on speaking for 80% of the duration of the interview, right? So whatever you are doing, you are thinking in your head, you should just speak that down. So I'm just writing this part of the code which will do this. So for that, I can write a for loop in which I will iterate through this and so on. So you will have to always communicate whatever you are thinking and what you are doing, right? Of course, the first part being coming up with an overall strategy, discussing with the interviewer, and then moving ahead with the solution. And during writing the solution, you have to always keep on speaking. Okay. Okay. So regarding this problem statement, let's just try to think fundamentally as to what we need to do actually to solve this problem. So list of n lists are there. Okay. We have to write a function which returns the intersection of all the n lists. Each list can have any number of elements. So what is the first thing that comes to mind? So if I just look at this example, right, and the answer, um, can you draw some conclusions? So can you just write in chat or in the Q&A as to what should be the first thing that I should be doing in terms of just looking at these lists and the output. So first thoughts, any first thoughts you can write in the chat section. Just want to see those. Iterate through the list. So you have to definitely iterate through that bigger list, right? So separate out. First, we have to separate out the list. Okay, I'll turn one element into set, separate a list, store in assigned variable. Okay, generate sets. So one more thing that I want you to know. So a lot of words I'm getting as sets, right? So if you see the problem statement, uh, it says that, so what is a set? Set will always have unique elements in it. Okay, so sets cannot be used in this case because if you make a set out of, let's say, the first list, it will return 5, 8 and 10, so it will drop the duplicates in a set, right? So you can just try it out. So I have just written 3 lists. Let me just run them. Okay, so just to demonstrate what a list, what a set does, right? So you see, it will only have unique elements. If you convert any list to a set, it will always have unique elements. So how do you proceed about this problem? So set is out of question, right? Of course you can, use set for any other purpose that you might want, but okay. So uh, Palash says that turn one list into a set and iterate through it, and while iterating count the multiples using count method on the original list. Okay, okay. So what is trying to say is that, let's say I pick any of the list, convert it into a set. So I get the unique elements. Okay, so Prashant says that I thought of the same strategy, right? So I think, yeah, so this looks logical because you get the unique set of elements. Then you can think of how do you store this repeatedness information, right? So in this case, 5, 8 and 10 maybe can be our keys, and against 5 we can write 3, saying that 5 has been repeated 3 times, 8 has been repeated 1 time, and 10 has been repeated 1 time. So in this way you can store this information, right? So that's correct. So yeah, Sanchita, okay, correct. Count of each element, and yep, yep, you are thinking in the right direction. Okay, so okay, so you are thinking in the right direction. So we need to store this information of how many times each of the elements are repeated in each of the lists, and then we can use that information to come up with the intersection. Okay, but then again, what other observations can you make, right? So these are the three uh, lists, and the output is 558, right? So uh, any other what is the first thing that comes to mind, right? So regarding the answer, so how is the answer connected to the input? uh, any correlations that you see between the answer and the question? One interesting comment I'm getting. So uh, we can compare two lists, find the common among the two, put it in a list, and then compare the new list with the third one. This is also good strategy, right? So um, there can be 3 lists, 5, 10, does not matter. You can write a code which finds whatever you want to do for 2 lists. Okay, so there can be one function which takes 2 lists and gives you the desired output, and you can just go on iterating with the same function many times. So let's say you have five uh, lists in this input. So take the first two, get the intersection, and with that intersection, take the third element, third list, and then again find the answer. With that answer, take compare with the fourth one, again come up with the solution, and so on, right? So uh, uh, you do not need to be intimidated by um, seeing that there is, okay, 10 lists or 20 lists. You have to just write for two and it will take care of it. Okay, so okay, Prashant is saying we can create a list of dictionaries. List of dictionaries. Every dictionary will consist the frequency of elements in corresponding list, and we can figure out with dictionaries. Okay, so what he is saying is that for every list, I can construct a dictionary which stores this information. So which element is repeated how many times. Okay, so for every list we can do that, and later we can compare. Okay, so this is one way, but one problem that I see here is that uh, need to store only the minimum ones, right? So you are using more memory in terms of space, right? To solve this problem, if you are converting every list into a dictionary and storing it, right? So you are using a space wise, you are using more space, right? So one of the key aspects that the interviewer also wants to look at is how efficiently are you code it up, right? So um, time wise and space wise, right? So how much time will your code take to run? So more the number of operations that you do, more time it will take, and more information you store, as in more variables you create to store more information, that consumes space in the memory, right? So it's good to have solutions which will, optimize on both of these aspects. Okay, so yeah, in this regard, I'm also getting one point, which is use the list of minimum length. Yeah, so this is also correct way to think about it. So why do we want to use that list of minimum length? So this is what I was talking about, right? So if you watch the output and the input closely, you will find the output always will be a subset of the list which has the minimum number of elements, right? So 558, here this is the list with the minimum number of elements. You can think about it that way, right? So if you want to come up with a solution within a second, fraction of a second, right? So you will, if you just have to take a guess of what is the answer, you will just say whichever list has minimum number of elements, just take that, right? Something like that, right? So because your answer cannot be the length of your output list cannot be more than the length of the minimum numbered list in the input, right? So it will always be a small subset of the smallest list. Okay, so this is kind of an optimization that you might want to do, because then your iterations becomes small, right? So of course, if all the lists have the same number of elements, it does not make sense to take this way, right? But let's say you start, your starting point is the minimum number of the list which has the minimum number of elements. You will of course do less work computation wise, right? So if I start with this, I do not have to concern myself with numbers like 10, 11, because those are not present in this minimum numbered list, right? So okay, okay. What all am I getting? So first traverse to first list, look the first value, and then check whether that value is present in rest of the list. If yes, put it in a new list and at the return. Okay. So sort is each list and compare each element index wise and append the common elements. um, Sorting will help, but index wise you will not be able to compare, because there can be just so there can be a case wherein you have a input which is something like this, right? So there can be a case wherein you have input something like this, uh, where all the elements are, let's say, distinct. So this is one possible case of an input that you might get. In this case, your output will be a empty list, right? So this will be your output in this case. Okay. So what else? Iterate through the list and convert each of the element to the list. Then find the intersection and count the number of intersecting elements. Okay. Okay, so a lot of ideas, right? So let's try to implement the minimum idea once, right? So we'll try to find out the list which has the minimum number of elements, and then we'll try to create a hash map of that uh, smallest list, right? So in that hash map, so hash map is nothing but a dictionary wherein you will hold this information, which number is repeated how many times. Okay. So so after that, what we can do is we can iterate through the keys of that hash map to figure out if there is some list in which the number of occurrences is less than whatever is there in the minimum length list. Okay. So let's start step by step, and then we will see. Okay. So overall strategy is to find out the list which has the least number of elements. Okay. And then we can just iterate through each of the elements or keys of the hash map of the least uh, of the smallest list. So it will have certain keys, and then using those keys we will find out for each key, right? So let's say in this case what I want to do is, let's say this is, if this is my list that I want to operate with, what I'm essentially saying is I want to figure this out first. I want to figure out this first. This is the smallest list. Then I want to figure out how do we create this kind of a setup. So here I'm just storing the information about how many times each of the elements are repeated in this smallest list. So first step is to come up with this. Second step is to come up with this. And maybe the third step is I'll just go on and see um, 5 is repeated 2 times in the smallest dictionary. So I will iterate over each of the list to see if uh, the frequency of 5 in any of the lists is less than 2. Okay. So if it is less than 2, that means in the final list or in the final intersection, uh, you will have to take that smaller number, right? Whatever comes up, right? So let's say if this was this, right? So if this was the question, you picked the smallest list, let's say this one. Okay. So let's say you have this list, right? So this is your input, let's say, right? So now um, this is the smallest list. I picked that up. I formed this dictionary, and then now I start comparing with each of the lists. So here in this list I have 5 repeated 3 times. So of course in that case uh, the third 5 will not feature in our final list, right? So um, 2 are at least common, so this will not change. Then 8 is there and 10 is there, right? So the frequency of 8 is 1 in the first list. Here also the frequency of 8 is 1, so it's okay, we'll not do anything. 10's frequency is 0, and of course here we are not looking at 10 itself, so we'll just look at 5, 7 and 8. So 5, uh, okay, so nothing changes in the first list. Second list is the same as this one, so nothing changes. Here, if when we iterate over the third list, we see that 5 is repeated only one time. Okay, so this in our answer we cannot have two fives, right? So I just need to update this value to 1 for now, because I saw that there is only one occurrence of 5, right? So in our final answer there cannot be two fives, right? So I just took that. 7 is repeated once, 8 is repeated once, so this is what I will end up with. And then finally what I will do is that I will use this final information to get the list, right? So 5 is repeated one time, 7 is repeated one time, and 8 is repeated one time, and so on. So this is how I will solve this problem. Okay, so in case of in case of this input, what will happen is that this will be the minimum numbered list, this will be the initial dictionary that we will create, and then what will happen is that 7 will not be found in the third list, so the frequency of 7 will become 0 when we once we start updating, right? And then we will end up with this kind of a dictionary wherein we'll say that 5 is repeated one no okay, so 5 will be repeated two times, 7 will be repeated 0 times, and 8 will be repeated one time, which is common in all the three. So you'll get 5, 7, 8. Okay, so this is the strategy, right? So let's start implementing this and see how we can move ahead. Okay. So to find out the list which has the minimum number of elements, we need to iterate over all the lists, right? So um, so let's just call this entire thing. Okay, so we have some inputs to start with, right? So let's start with that. So for list, so this is the list of lists, right? So whenever we iterate over that, each so this will basically contain each of the lists in the list of lists, right? So what you can do is that just print this out to see what is happening, right? So list of lists can be anything, so we can try out with this as well. So you see this is working. So no, just iterating over this bigger list and printing out each of the lists, right? So this is how I will start with. Okay, this will print things up, then we can move on to the next part, which is uh, let's say minimum length, right? So I need a variable in which I will store this information, right? The length of each list. So basically it's nothing but you storing some information while iterating and updating that information as and when you get more information, right? So let's just store this in a minimum length variable. So I'm setting it to 0, let's say. Okay. uh, or maybe I can initialize this min length with the length of the first list that I observe. Okay. So So while coding, you should remember that your variable names should be, self-explanatory, right? So the length of the variable does not matter. It should be readable, and you should be able to understand uh, which variable stores what is information, right? And this also makes the code look nice, and the interviewer will relate more to your code if you write it that way instead of just writing I, J, K, M, and so on. So the variable names should be intuitive to read. Okay. So uh, along with me, you can start coding as to how you will go ahead and find out the um, list which has the minimum number of elements. Okay. So I have divided this problem into a sub problem. So let's just start to find out the list which has the minimum number of elements. Okay, which list is that? Okay, so what I want to do is that for testing purpose, I'm putting this in a variable called list of lists. Okay, so so I just want to store the length here so that I can remember, so that my code at any point can remember what is the minimum length that I have found till now. Okay. So we need to store this information somehow, right? So I'm just initializing this bit with the length of the first list, right? So this is just an initialization. Later on, if I get a list which is less than uh, which is smaller than the first list, I will update this information and so on. Okay. So if the length of the list is less than whatever we have initialized with, then I know that I have to replace I have to store this information and update the min length, which will then become min of. Okay, so uh, till this part it's very simple, right? So iterating over all the lists, and if I find a list which is less than the minimum length whatever I have initialized with, I will update this information, right? And I'll also say that the minimum the list which has the minimum number of elements is uh, this, right? So this information also I will put. So why do we need to initialize this? Because we want to compare at each step with some value and see if my decision changes in that iteration, right? So here what I'm doing is that, of course, storing the minimum length information after each iteration. And if this case happens, right? If this case happens, I will say that the minimum length list is this list, right? So this will keep on updating, right? So initially what I was assuming is that, let's say, these are the two informations that I'm initially assuming to initialize this, right? So starting with the first element, saying that this is has the minimum number of this is the smallest one, and then I iterate over each list to figure out which one is which one is actually the smallest one. Okay, so let's just check if this bit of code is working. So it's in an interview, it's very important that you write separate functions for each of your tasks, right? So if it's a big question, you want to divide that problem into sub problems and have a function for each of the sub problems. So this is what we call as modularity. So you need to write modular code. Okay. So let's just so if you have already done, right, if you have already completed this, try to think of some other ways to do this same problem. Okay. Okay, good. um, so this function name has to be also intuitive, right? So what this function is doing, this function is basically giving me get minimum length list. So I pass the length list of lists to this function and it gives me the minimum length list. Okay, so this is our function. So once I have written this, let's just test this out if it is working fine. Okay, so okay, so it is working fine. So in this case, it is returning me the second list as the smallest one. Okay, so this seems to be working fine. Let's just try out some other uh, examples that I have already said. In this case, it should be empty. Yeah. So because there was a set with no elements. Is this working with this as well? Let's just test that. So for this list, this one is coming up. So this code is working fine to get the minimum length list. Okay. So now we need to create a hash map or a information dictionary, right? So which stores the information of this min length list. Okay. So okay, so to do that, what do I need to do? So I need to iterate over each of the elements in this list. Whenever a new element is encountered, that frequency will be 1. But for an old element, whatever is the old frequency, I just need to add that, right? So this will be my idea to code up the frequency map. So what I am essentially saying is, let's just so till this part, everyone has coded in their notebook min length list. Can I just get a heads up if you have coded till this part? Okay, cool. Uh, cool. Let's say I call it frequency map, right? So frequency map is the name of the dictionary that I want to call it. So this is an empty dictionary wherein I want to store information, right? So I'm working with this list as of now. So here I want to get something like this, right? So my final result should be something like this. For this list, I want to create something like this. How do we do that? Let's just iterate over each of the elements. Okay. And if I see a new element, I just need to add that to the frequency map with a frequency of 1. But if I see uh, an element which is already there in the frequency map, I need to increment the count while iterating, right? Okay. So for element in this list, so let's just call it min length list. So this will be one list. I want to try it out at some point. So let me just store this information. Okay. Okay. Yeah. So just iterating over each and every element. Let me just write something like if lm is already there in frequency map keys, right? So uh, frequency map dot keys. So if lm is already there, I need to do something. Then if it is not there, I need to do something else, right? So here what we need to do is, if it is already there, I want to take that value and increment it, right? So whatever is the value associated with this key lm, I need to fetch that and increment it by 1, right? So let's just do that. So right, so from the frequency map, what is the value of this element that is already there? I'll take that and then I will increment it with 1. Okay, so that is there. Else what I will do is, I'll just add a new element to the dictionary, right? So frequency lm is equal to 1 if this is a new element. For new element, I just need to write this, right? So um, Prashant says that what we can do is, we can we can use try except here instead of if else. So what he's saying is that, let's say I write this part of the code in try, right? So it will throw me an error whenever this element is not found in the dictionary, right? And then it will go to the except part wherein I can write this, right? So that is one way to do it. But this is more intuitive, right? So uh, using try except here means that, you are taking unconventional route which is not intuitive to solve the problem, right? So essentially, your code will only fail when this condition happens. But when you write this condition, it says that you are checking for it, right? So much more intuitive in that manner. Okay, so I got this. I want to check this if it is working. So min length list. Let me just check how the frequency map got populated. Yeah, so I'm able to get whatever I was wanting to achieve, right? So yeah, let's move on to the next part now. Okay, so frequency map is something which I am able to build. So this is a generic function. So given any list, it will build the frequency map, right? So I'll just make this as a function. So get frequency map. This will take any list and give you that frequency map, right? So it is a very generic function, right? So just write okay. So I have written a function which will do that job for me. Uh, Return frequency. Now let's say I go to, so I can try out this function first. So I'm giving you sufficient time to code this up. So try to follow along and write these codes in your notebook itself, notebook also, right? So let's me try this with random elements. Let me just check. So this was the list that I passed. So 1 is repeated 1 time, 3 is repeated 2 times, 4 is repeated once, 5 is repeated 3 times, 6 is once, 7 is once, which is okay. So I think this is working quite well. Okay. So the next part would be to okay. So the next part is a bit tricky, wherein now you have to uh, take the final frequency map, take each of its keys and find out the corresponding count in all the lists, right? So the first thing that I know is I have to definitely iterate over whatever frequency map I'm getting, right? So let me just store this frequency map information. So min length list will go here, and then let me just store this in, let's say, min list minimum length list frequency map. So this is the dictionary that I will be using. So this is that dictionary, minimum length lists frequency map, right? So this is the frequency map of the list which has the minimum number of elements. Okay. Now I will iterate through each of the keys in this dictionary, right? So for key, maybe value as well, and so since I have the editor now with me, so what I will do is that I'll just try to print out the keys and the values, whether I'm able to iterate correctly or not, right? So okay, so 5 2 5 2, so key value pairs are getting printed, which is working. So okay, so now I have all the keys. For each key I need to look up in all the lists, right? So now okay, so again, so I have to iterate over all the lists, this is for sure. So for list in list of lists. Now for every list, what do I need to check? What is the number of times this particular key has been repeated in this particular list, right? So print, let's say, count of, so we can just write, so basically what we are essentially doing is, in this list, what is the count of key, right? So this will return me the count of key. Okay. uh now what do we need to do? So this is some value, right? So this is the count of this key in the list underscore variable, right? So this will go over in each of the list of lists, right? So okay, so now this value I need to always compare with the value, right? So if this value is uh, less than this value, I need to update it. Otherwise, this value is okay, right? So, okay. So let's just do that. So if value is greater than this, then I need to update my value. Otherwise, it is fine. Okay. If this is the case, I need to update my value. So let me just write this. For this key, I need to update the value with the new value, which is the this count, right? Okay. So yeah, this is this seems to work, right? So we'll update the information there. Okay. So will this work? Let's just try this out uh, and see if this is working. So let's just wrap this function. What is this inside a function? Okay, so since I have ran this, can I just see as to what is stored now? Okay, so 7 was set to 0, 8 is 1, 5 is 2. So if I just convert this uh, into a list, this information, I will get the answer, right? So okay, so let me just try this out. Right, so two functions I have already written, and using those functions I'm coming up with certain things, right? So uh, let's say I get this final no hash map. I need to convert it into a list format wherein uh, the item will be repeated, key will be repeated as many times as its frequency, right? So this is also one function altogether which will serve this purpose for any generic list, right? So let's just uh, write that function. So def create list from frequency map. So this function will essentially take this kind of information and give us the output in the format that we want, right? So, okay. This can be any list, right? So any map. So I need to, uh, 5 should be repeated 2 times, and this, this, okay. So I can just write it this way: for key comma value in this frequency map dot items, my list will be final list that I need to output will be. So does list addition work? So let me just check that once. Let's say I do this, what will happen? Okay. Okay, so what I can write is final list. Let's say write key, and key will be repeated value times, right? So this is something that I can write. Okay. So what I'm essentially doing here is that I'm creating a list from the frequency map. So if I get this kind of information, I want to make it, 558, right? So how do we do that? So in that list, the key will be repeated as many times as the value, right, in that final list, right? So uh, so we can just initialize the final list, a empty list, and then iterate over each of the items, right? So key value pairs will extract, right, through from this dictionary, and in the final list we will start appending this information, right? So 5 is repeated 2 times, so that means I just created one dictionary. So it's like saying 5 repeated 2 times, right? So this is the this will be the value of final list in the first iteration, and then again what will happen is that plus, uh, 7 will be repeated 0 times, so 7 into 0, plus 8 will be repeated 1 time. This is how we are getting the final list. Okay, so okay, so I have written these all of these functions. uh, so can you tell me uh, where will this do you see any errors in the code, um, especially in this part, because we have not tested if this is working as a function separately, right? So we have, so these are known as helper functions, right? So whatever functions we have created, right, which will help us in solving the bigger problem, so these are known as helper functions, right? So we created 3 helper functions today, right? So let me just compile all of them so that they are kept in one place. Let me also just name them so that I know what it is doing, right? So let me just write a documentation. So this function returns the list, a list of lists as an input and returns the list with the least number of elements. Okay. Now similarly we can write for this as well, right? So this function creates a frequency map in a given list. This function creates a list from a frequency map. Okay. So now what we need to do is essentially use these three functions to come up with our answer, right? So uh, list of list, I'm passing to get min length list to get the minimum length list. Okay, this is how this looks. Then I can pass this minimum length list to get the frequency map. Okay, this is what I get. Now what I'm essentially doing is uh, so I'm iterating over each and every key in the min length list frequency map, and I'm comparing the value that it stores with the count of the key in the list which is in that current iteration, right? So uh, and then whenever I see a case like this, right? So whenever I see a case that five, I have observed a list wherein there is less number of fives than this min length list frequency map. In that case, I need to update that information, right? So this is how want to go about it. So let's just try out this whole thing. Let's just wrap this function, right? All of these codes in one single function, which is, let's say, def intersection list of lists. What I will do is that I'll just write these things here. Again, so after doing this, I need to convert this into the final list, right? So there is this function that create list from frequency map. So we'll be taking the help of this to get the final result. Okay, so let me just remove all of this. So I wrote this function, right? So essentially taking list of lists, getting the minimum, get frequency map from that, right, for the minimum one, and then using that I need to create uh, recreate this frequency map which stores the minimum number of occurrence in each of the lists, right? And once I have gotten that part done, I will store the final result uh, from the frequency map, and then I'll return it, right? So let me just try to run it and see if this is working. Create list from frequency map. This part I have not run. Yeah, so for this it is saying 558, which seems to be correct, right? So we'll take a lot of test cases and see if this intersection is working. Can we add while loop at end as while value? While value. Okay. No. Okay. So how many of you are able to follow till this part? Can you write in chat? So completed till this part, everyone? Okay. So this function returns the intersection of list of lists. Right? So once you're done, you have to submit it under guided project, okay, in your assignment submission portal. So okay, so anyone has any doubts in this part, in any of the functions that I wrote? No, right? So okay, so let's just try out a few test cases so that we are able to understand whether this is failing or not, right? So let's just try out all of these, right? uh, so the first one is essentially the same, intersection of list 0. Okay, so in this case I'm getting the answer, so you can try out your own test cases. Just write a few test cases where you think this might fail, right? And see if it is working correctly. uh, list 1. Okay, this is working. Lists 2. Okay, nothing was in common. Okay, let's just have, let's have more test cases. So these are kind of similar. Let's just take two strings to be empty. So what will happen? Two lists to be empty. Yeah, so this is also working fine. Let's just take one element in each of the list, but that is not getting repeated. Okay, so this is also working correctly. Uh, if there is, let's say, one common element in one of all of them, okay. If let's say it is repeated multiple times in one, two times in this, and one time in this, okay. If let's say I add one more here, yep. So it seems to work well for all the test cases, right? So one more test case can be, this list can be totally empty. What will happen? Let's just test. Yeah, so this is throwing an error. So, and you said that you will pass a list of lists, and you then did not pass any list, right? So you should be able to handle this case in your code itself, in your final code itself, right? So then just write if length of list of lists is 0, return empty list, right? So this is one check that I kept. So now this will work. Okay. So I pass a list of empty lists. Yeah, so it is working. So yeah, I think we were able to come up to a solution. So you can think of many other approaches. So any question can have many approaches, right? So feel free to try out on your own. So you're asking list.count key. Okay, so what we are doing is that here in this part, for each key in the minimum length list frequency map, right? We are essentially we want to compare this value with the count of that key in all the lists one by one, right? So we are iterating in all the lists one by one, figuring out if the count of this key that we have in our mil length list, if the count of this in any of the list is less than the value that we have already stored, okay, then we will update it, right? Okay, so you saw an example, right? So I'll just explain it again. So let's say you have this list of lists, right? So what we are essentially doing is that we figured out this is the minimum length list. Then we figured out that this will be the frequency map of it. Then we figured out that, okay, uh, 5 is repeated, the count of 5 is, 3 here, okay, which is greater than 2. So you do not need to do anything. But if it is, let's say, occurring only once, right, then we need to update this value to 1, right, instead of 2. So that is what this count key is doing. Okay, so essentially after that iteration, you will end up with something like this for this list of lists. So 7 will get updated to 0 because when you do no this dot count 0, count 7, you will get 0, right? So this value gets updated here. Of course 8 is on repeated in all of the strings, so this is there. So this is what you will end up with after that iteration, and then you can finally convert it to a format which says something like this. Okay, so